Today we're going to be talking about proving parallel lines using two-column proofs. A proof is a formal series of statements showing that if one thing is true, something else necessarily follows from it. Everything must follow from what is above it. So let's look at example 1 here. In example 1, given that DB bisects angle ADC, we have to prove that angle 2 is congruent to angle 3. So we know that DB bisects angle ADC because it is given to us. Next, we know that angle 1 is congruent to angle 2 because of the definition, I'm going to abbreviate, of perpendicular bisectors, which tells us that this bisector cuts angle ADC into two equal halves, and those halves are angle 1 and angle 2. So angle 1 is congruent to angle 2. Next, we have that angle 1 is congruent to angle 3 because of the definition of vertical angles. Angle 1 and angle 3 are vertical angles, and the definition of vertical angles tell us that vertical angles are congruent. We moved on to angle 1 being congruent to angle 3 because we had to use the step before to get to the next step. There was nothing really we could do with angle 2, but we could use angle 1 to find something else, which was angle 3. So that's why we moved to that. Next, we have that angle 3 is congruent to angle 1, and this is because of the symmetric property of congruence, which we just reversed that angle 1 is congruent to angle 3. We just switched those around, which we could do because of this property. Next, we have that angle 3 is congruent to angle 2, and this is because of the transitive property of congruence. So we know that angle 1 is congruent to angle 2, and we know that angle 1 is congruent to angle 3. So by the transitive property of congruence, we could just kind of skip the middleman, which is angle 1, and say that angle 3 is congruent to angle 2. So finally, we have what we set out to prove originally, that angle 2 is congruent to angle 3, which we were able to say, once again, because of the symmetric property of congruence. So that's our answer for example 1. Let's move on to example 2 for more practice. So, in example 2, given that line L is parallel to line M, we must prove that the measure of angle 1 equals the measure of angle 2. So we know that L is parallel to M because it is given to us in the original statement. And now we know that angle 1 is congruent to angle 3 because corresponding angles are congruent. So, angle 1 and angle 3 are corresponding angles. Next, we have that angle 3 is congruent to angle 2. Believe it or not, angle 3 and angle 2 are also corresponding angles. So we can once again say that our reason for this is that corresponding angles are congruent. As you can see, I'm abbreviating for congruent, but you get what I mean. So, next, we have that angle 1 is congruent to angle 2. This is because of the transitive property of congruence. Since angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, once again, we could just cut out the middleman, that was angle 3, and say that angle 1 is congruent to angle 2. So finally, we have what we initially set out to prove, that the measure of angle 1 is equal to the measure of angle 2, and this is because of the definition of congruent angles. Okay, so that's example 2. Lastly, let's talk about example 3. So, given that R is parallel to S, we have to prove that angle 3 is supplementary to angle 6. So we know that R is parallel to S because it is given to us. We know that angle 2 is congruent to angle 3 because vertical angles are congruent. Next, we have that angle 3 and angle 5 are supplementary. This is because they are consecutive interior angles. And consecutive interior angles are congruent. They're consecutive because they're on the same side, and they're interior because they're both inside of the parallel lines. So now we have that the measure of angle 3 plus the measure of angle 5 equals 180 degrees, and this is because of the definition of supplementary angles. Next, we have that angle 5 is congruent to angle 6, and this is because they are vertical angles, and those are congruent. So now we have that the measure of angle 5 is equal to the measure of angle 6, and this is just because of the definition of congruent angles, which we have again. So next we have that the measure of angle 3 plus the measure of angle 6 equals 180 degrees. And this is because of the substitution, let me scroll down for a second, substitution property of congruence. Now I see that you can't really see the picture, so I'll move it down for us if I can. There we go. Alright. So lastly, we have what we initially sought out to prove, which is that angle 3 is supplementary to angle 6, and this is because supplementary angles add up to 180 degrees. So that proves example 3. So this is what I wanted to talk to you about two-column proofs. This time I gave you the original statements and we just had to talk about why those were true, but next time we're going to be working a bit on how to do these two-column proofs without me giving you any information other than the original statement. So like for example 3, it's given that R is parallel to S, prove that angle 3 is supplementary to angle 6. So you'll only be given that next time, and you have to prove that angle 3 is supplementary to angle 6, or whatever it is that I ask you to prove. So we'll be talking about that next time. In the meantime, why don't you practice these yourselves, and I will talk to you again next class.